All right. We are officially live with Dr. Nelson and the marvelous Dr. Stephanie Rimka, who we've had on before with a really great conversation. And we're just talking about, all right, what are we talking about? And last time I think we kind of mentioned the glycocalyx as something I know you're very, very passionate about, and I am too. And deuterium depleted water and deuterium and how that contributes to our ill health. And maybe you can, you could step on that a little bit, but we're open to questions here on a live today. We're
now, so where are you with like in your group? Where are we live?
Yeah,
we're on YouTube, Instagram, Facebook. Are you on Kills Mighty Tribe?
No, I'm not on Kills Mighty Tribe. X, LinkedIn. I don't know. We're sort of like.
Well, I think I remember us talking. We were talking about carnivore, the benefits of carnivore, the proper human diet, and I think we ended like I was like, well, I think the most impressive thing, why we get these incredible. Radical improvements in mental health that people just don't want to believe. I don't understand. It's not, what do you mean? It's easy to understand. Like from a number of reasons, microbiome, inflammation, your brain on fire. But I thought the most powerful thing that doesn't probably get talked about enough because it's so sciencey is deuterium and deuterium depletion and the involvement of deuterium in mental health issues and how it can cause mania and psychosis and depression. And people don't even have to think about deuterium. They don't have to measure it. They don't have to know what it is, this heavy isotope of hydrogen. And as they go eating, they switch from these high deuterium diets, which are high carb diets, to the lowest deuterium diet, which is meat and fats, animal meats and animal fats. You just naturally give the body a chance to deplete itself of this deuterium. And I just actually spoke in Boise last week at a functional medicine conference about trauma. And so I was talking about trauma and I was talking about what happens, the biology of trauma, the autonomic nervous system. But in a small subsection on a couple of the slides, I had to remind them, because we focus on mitochondrial repair, that why is glycolysis and the TCA cycle so complicated? Like, why do we have 10 enzymatic steps and then 9 enzymatic steps to do this? The process of dehydrating, glucose to become pyruvate. Why is this so complicated? This shouldn't be this big of a deal. And then to rehydrate it again in the TCA cycle, all of it is to strip deuterium out of the equation to protect the mitochondria from the trauma that deuterium, the heavy isotope of hydrogen, does. So when you look at it from that way, where's the most concentration of, mitochondria outside of a woman's ovaries with the egg potential? It's the brain. So if I start dumping a bunch of deuterium and I start breaking all the mitochondria, well, why wouldn't we? Are going to have poor brain function, which is always going to lead to poor mental health. That's how it works. Brain health equals mental health. Mental health is not some thoughts, it is structure, and function. So that's where we kind of left off. So there's like the groundwork of what maybe we can dive into all that.
Well, so the brain is obviously that magical, mysterious, functioning organ system, or is it just an organ? Is it greater than that? And you talk about trauma, inflammation, dysfunction, and there's a lot of physical illnesses that express themselves in mental disorders, or do the mental disorders express themselves in physical, and are they really separate? And maybe you could talk a little bit about what is hydrogen atom essentially, or what is deuterium and what is non-deuterium, a little bit of the science in that, and how our illnesses are related to this sort of sciencey things. And I know Laszlo Boros, and talked to him a lot about this in the past. We haven't done it recently, and so I think it would be a good time to sort of bring this out, and what your thoughts are on what's the cause of all of this.
Well, deuterium is naturally occurring. So Laszlo is the best, I think, to talk about this, but can sometimes be like really heady for some people to understand. And so to get through some of the accent and then all the science terms, if people are like, I know what he just said was really important, but I don't understand what he just said, right? He basically is like, never eat fruit ever again because it's poison. You want to go crazy? Give your children, fruit. And so this is where we're at, right? So people think of water as H2O, right? We're very familiar with learning that in like 5th grade or whatever. 2 hydrogens and an oxygen, we put them together. It's this little polar thing. It's this very special structure. Well, water is a very unique property. It's this very unique element that we have. And it's, we are these bags of water, a very special kind of structured water. And everything we're doing is about water holding memory, water. So for me, the brain is an organ, it is a structure, but it's also an antenna receiver. So it's picking up a lot of information from the field. Hang on, my dog's gonna do this in and out thing. In and out, my dog owns me. Hydrogen is this first element on the periodic table, and it's very, very special, and it's very, very unique. And if somebody would have told us when we were in like biochem in grad school, we maybe would have paid more attention to all of this, but we were just trying to get through those courses, we're like, what? We're just trying to get through physics. And now I go, we should have spent way more time on this. So hydrogen is the simplest. We just have this very low weight. We have proton, neutrons, electrons. You guys remember those things, right? We have this thing in the nucleus that gives it weight, that gives something weight, and these little electrons are supposed to be flying around it. That's the model we have of the best we understand it. We don't even know if we're right about this. We could be totally wrong, but it's what we think. If you make the middle of the hydrogen, you put another element, one of those neutrons in there, you make it heavier. You make it double the weight. So you basically take like a tennis ball and you make it, instead of weighing a tennis ball weight, you make it heavy and the size of a bowling ball. So tennis balls are supposed to be going through the system. That's hydrogen, through the electron transport chain of the mitochondria. Occasionally, I forget the number, it's like 1 in 2,000 hydrogen or something like that, or 1 in 1,500, I forget all the numbers, one of you guys might know. Occasionally, like that 1 in 2,000 times or whatever, a bowling ball gets thrown into electron transport. That breaks the whole, it starts breaking it because it's too big and it's too heavy. You can't play tennis with a bowling ball. So if if you're playing that and somebody throws it, you're like, oh God, and it's going to break your racket and it's going to break the whole thing and it's a whole mess. Then you got to clean it up. That's what these deuteriums, they're naturally occurring, and it occurs more in the hydrogen water, the H2O. So it's like H2O, H3O, HDO. So we have these deuteriums that come in there instead of the hydrogen. The hotter it gets, the hotter the water is. So near the equator, there's just more deuterium. So it's just the way, it's a natural isotope. It's just, we have isotopes of things. So there's another isotope of hydrogen, but it's like radioactive, it's trillium. Mm-hmm. Like that'll kill you. You know what I mean? So the deuterium, there's tons of it in the water at the equator, very little in the water, like up at the north, like in Siberia. So where you live naturally kind of determines your deuterium content in your body, because what's in the water, is it what's in the soil, is what's in the food. So stuff that the water they drink in Siberia is very low deuterium. And they don't really eat that many plants because it's all snowy. They're almost all carnivores anyway. So they're not eating any deuterium. They're not drinking any deuterium. So their deuterium levels are incredibly low. And it's definitely correlated to aging, longevity, and disease. So they live very long up in Siberia, in Russia, right? University of Tomsk has done a lot of studies on that. So there's that. So, right, we come down to where I live in Atlanta. My spring water here, clean water, is just very high in deuterium. I've tested it. It's just how it is. So people that live down here are consuming a lot more deuterium. So we have more load in the system. So the mitochondria have more being thrown in. So there's more repair that has to happen. So it slows down how quickly the mitochondria can work, because there's a motor that spins, and it's like, 2,000 RPM faster than a Corvette or a Ferrari. Like they spin so fast, like the revolutions per minute. It's unbelievable. What is it? 7,000 or 8,000 revolutions per minute or something like that, or something. It's crazy, per second. These are stupid numbers. I don't remember all of them, Rob, but
Which kind of, and I just want to, and I really appreciate it. So just for everyone who's here, we're talking about deuterium. We're talking about energy in essence.
Yeah.
And I think about the clouds. I fly airplanes and I see these clouds, and obviously weather is a critical part. And around the equator, there tends to be more storms than there are that. And I know that depending on the time of the year, we're going to get more thunderstorms. And we think about the electrical energy that is contained in these particular storms. And really, it's about water molecules and the attraction and the electrical energy that somehow is built up in all this. I'm wondering if that has something to do with this. And I like the analogy of a bowling ball versus a tennis ball, because in order for them to move the hydrogen around, because that's a lot of what's going on. We're taking hydrogen from acetyl-CoA, from fatty acids, and we get it from sugars and from amino acids also. Yeah. They're moving these things around. So if it's heavier, it's harder to move, but it sounds like there may be a little bit more electrical energy that may be a factor in heating things up or damaging things.
Yeah, I mean, I don't really know, but I mean, the voltage, it is a voltage potential, right? So we're dealing with the hydrogen, that voltage gradient of the inner mitochondrial membrane and outer mitochondrial membrane, and then the mitochondria and the cytosol, and then intracellular and extracellular. Everything is about voltage gradients, right? We're doing these gradient potentials. So yes, actually, even though that storm image, I don't know how it totally plays in what the deuterium is actually doing as far as that, the charge that it's causing or the lack of charge, because I'm very concerned with patients about charge. Like that's what I'm measuring. So when I do an EEG on a brain, it's looking at charge, right? And that's why I don't do neurofeedback on vegans. They cannot hold a charge. Like that is the thing. It took me a few years to figure out. Doing any brain therapy with neuroplasticity on a vegan brain cannot hold. We can correct it. It won't hold. So it's like we get them to 9 volts and they drain to 3 volts. We get them to 9 volts, they just constantly drain. And it's most likely the DHA. I mean, there's only so many things in the brain. I got to have tons of DHA, zinc, copper, B vitamins, magnesium, choline. There's not that many things you need to care about inside the brain. But when you load it up with a lot of deuterium, and that's what's in carbs and sugar. So deuterium is in foods that have a lot of carbohydrates, because it gets inserted. Carbohydrates, a bunch of carbons with waters on it, and so the water has the heavy hydrogens. So that's what's going on. So there's fancy, expensive deuterium depleted water. I rarely recommend that unless I'm dealing with an infertility case or something like that. Like infertility, I think it's really like deuterium is one of the biggest causes of infertility to me.
I know you explained it a couple of minutes ago.
You can explain it maybe better, Nelson.
No. I don't. Actually, I don't. But I just created this graphic in a little bit, and so you can probably take us through that very quickly.
Yeah, so we'll look at, so like say what we have is hydrogen, right? We have a very simple, in the center, the nucleus, we got one thing. We look at it like that. Deuterium's got these 2 things, and then tritium has 3 things. It's just heavier in the middle. A better analogy is maybe you're playing pool, and those balls, instead of the 8 ball, it's somebody sticks the bowling ball. Well, how are you going to do that? And that's what happens occasionally. So tritium, I forget where that's like a rare thing. We don't have to deal with it. They use it for nuclear stuff. It's like they're doing it's not good. But I really do forget the number. I feel like it's 1 in 2,000 or something like that. Like there's 1 deuterium to every 2,000 hydrogens. But when you have the ATP synthase, that motor, that last step in the electron transport chain, and the mitochondria are doing, everything. They're these incredible bugs. They're not human. We have the symbiotic relationship with a completely different organism that decided, hey, this is what I'll do. I'll make all your water for you. I'll keep you hydrated inside. I'll make this very clean water that keeps you detoxified, keeps things out of the mitochondria, keeps things out of your nucleus. I'm going to protect your DNA. I'm going to make this exclusion zone water for you. I'm going to make all this ATP. I'll help you, use the oxygen to make energy and make signal molecules. We'll do all the work for you. We'll lend you our DNA. You don't need that much DNA. We're going to do things for you all over your body. All you need to do is keep us safe inside your cells so we don't die out in this horrible atmosphere. We're like, cool, great deal. So we have a very symbiotic relationship with these things. They're not human. It's a whole other species inside of us doing this, these mitochondria. So when we throw these things in, occasionally it just breaks them. They just start, and they just don't work as well. It's like if I throw, water into my gas tank occasionally, my car will run, but then it'll choke every now and then it'll run, and then it'll choke, and then it'll go, and it'll choke. That's what's happening. And if that happens tens of thousands of times more than we're capable of handling, we have decreased function. So the charge goes down because we can't make as much. The voltage gradient we can't do as well. We can't exclude, the hydrogen, keep the electron, the barrier that way. We can't make as much ATP. We can't utilize oxygen the same. We don't make as much exclusion zone water that's pushing toxins out. So then things can get inside and start damaging more. We can't keep the lead out. We can't keep the mold out. We can't keep the oxalates out. And the cells become dehydrated. Once we have dehydration, we're always going to lose charge. We always can't make the potential the same because water with the salts is what's conductive, and that's what's creating that charge. And life, you see people when they're dying, the charge is going down. You can see it. It's like a battery. It's like this. It's no different. We're at 14%. Now we're at 5. When your phone gets to 5%, it starts acting really wonky if you don't charge it in. It just doesn't even scroll right. That's what's going on. So that's
when we get to 0%, we're dead.
Yeah.
Where does the glycocalyx come into this, and how deuterium may damage the glycocalyx, which is also responsible for how the electrical charge is maintained, because it holds the structured water, and once the glycocalyx is broken down, the water structure and the function of the nerve fibers and all of that, and the cellular membranes are damaged, along with the mitochondrial membranes.
Yeah. I don't know. That might be a Laszlo Boros question. The way I think of, destruction to the glycocalyx, deuterium is involved because it's in sugars. It's really high concentration in glucose, fructose, right? That's, high blood glucose, high insulin rips apart the glycocalyx. So I know that. I don't know about the biophysics of what deuterium actually, if that's in and of itself has a direct impact, or if it's more indirect based upon high glucose and high blood pressure and all of that, which damages, the glycocalyx.
So trillium, one second. I just want to ask one thing, because that great graph that you showed, the pictures of trillium and deuterium, they're more unstable. Right. And so we know that unstable molecules, atoms, release energy that can damage our cells and our functionality of our structures, like the nanomotors that are working. I always imagine they're working at nearly the speed of light, because they're all electromolecular reactions at a very microscopic level. And that the tritium is not very abundant in our natural environment, is it?
No, it's not. I mean, that's like a thing that, as far as I'm concerned, you don't ever need to worry about it. Like, it's not, you're not going to encounter that. As far as, I haven't gone really down that rabbit hole. It's like, I don't need to worry about that. But I'm curious about how deuterium would function right on. What does it do to the glycocalyx? That is a Hans Vink question, the glycocalyx expert, ask him. I don't know. If anybody's looked at it, it's him.
Well, it will be interesting, because I hear that Esther's here, and she says that Laszlo's also listening in, and always, and I don't know if, it's, that, and
listen, he can hop on any minute, take my place.
Well, I was
He's
just going to throw in a stream link for Laszlo if he's listening, and I threw a link in there because it'd be interesting to get his point of view in this, because and so let me ask you, how are you approaching the brain dysfunction, the trauma, the inflammation, and how have you seen people benefiting from deuterium depletion? And when we say that, we're really talking about a low carb, high fat dietary changes. And are there other things that you think can also aid in that?
Yeah, there are a lot of other things. I was testing people for it. Like if they want to spend the money, it's not expensive. We can do a quick deuterium test and do a pre and a post, but most people don't need that. And I don't think most people even care about the conversation. They just want to feel better. They know they don't feel well. If you're riddled with anxiety or having panic attacks or depressed or insomnia, you're not doing well or have compulsions. So I've done a lot of that. And I would see it consistently doing what it did. And I'm like, this works. It's like, I know it works. I don't need to waste people's $300 two times. Like, I mean, for what? Right. So if they want to, I'll do it. I think it's fun for fertility cases. Like, I think that's worth tracking. I think cancer patients like to track, but for most mental health, I don't actually test at all. I don't need that for that. I look at other markers and track those, like zinc and things like that are really, really super important to me. We just hit them. I just go, I'm pretty carnivore. At this point, I don't play around with it. I have gotten the best results clinically with MS, ulcerative colitis, Crohn's disease, depression, bipolar, borderline, schizophrenia. I don't care what it is. I get way better results with carnivore than I do with keto, than I do with ketovore, or anything in between. So even if I only get like a 90-day reset, and then I have them bring some things in and we're more ketovore, that's fine. I prefer 100% carnivore, like, I don't know, super, super hyper carnivore versus the 70% hyper carnivore category when I'm dealing with something very, very serious with the brain. I don't want, now, again, I'm going to titrate because I'm going to have to deal with oxalate dumping and other in their liver. I do have to look at their stomach acid. I mean, in the liver function of pancreas, just like you do, I got to see what I can do. Like, are they a vegan? Okay, I don't just rip it all away and you're eating meat 3 times a day, because they don't have the tolerance. They don't even have the capacity. They have no stomach acid. So I have to deal with but I prefer and get the best results, hands down, when we go 100% very, very strict carnivore. I'll let a little coffee be in there. I'll let a little tea maybe be in there, a little bit of that kind of stuff, but not any plant foods that they're eating. I do use herbs and things like that medicinally, because I am going to be changing their microbiome and bringing inflammation down. I do use plants like medicine, whether I'm talking oregano or marijuana. I'm just going to tell the truth. Okay. So there's that. So I definitely do that. And they feel it so quickly. People can feel this lifting of a fog in days, sometimes days. So when you make somebody feel better, they're ready to latch onto it, and it makes the effort worth it to them. So we just have to go with, and we coach them every week. We can't just see somebody like that once a month. We must see them pretty frequently to change things for them. We might have to throw a little, black tea for oxalates in there or something, but I take them full blown into it right away.
Do you normally transition people rapidly into carnivore? Let's say someone comes to you, they're dealing with you, but they're having a regular diet. Do you transition them? If you convince them, first of all, if they are willing, do you transition them over how many days or weeks, or do you just jump right away?
It depends on the personality. So I think the more comfortable thing, if it's a standard American diet, I think the more comfortable thing is to do a 4 to 6 week kind of a transition, maybe longer, but some people can't do that. They're highly food addicted. There's just, they're very black and white. They want to commit, especially men. If I'm like, listen, if they have a high tolerance for discomfort, they just want to do it. They don't want to go gently. They want to hit it hard. Men have a higher tolerance often for that. And so I have to honor military guys is how they are. They just want to do it, right? I'm going to have to probably move my long cookie. So women, though, are a little bit different. And I have to honor if they can digest, right? A lot of them have no appetite anymore. They're like, oh God, I don't even want to eat meat. It's so gross. I'm like, I know, that's because you have no stomach acid, you're B6 and zinc deficient. Once I get that fixed, you're going to be craving it. So I have to work with that. I may have to assess that and get the stomach acid up and deal with the liver. I may have to just detox and drain that liver for 30 days, just the fatty, the congested fatty liver is blocking up function. And I had to get some bile flow going so they can even have an appetite for the meat again, right? I might do some fasting to help, I might do a water fast. It just really is individual. I don't think there's I don't think there's a safe cookie cutter way to say that. So some people it's taken me 3 months. Some people it's taken 3 days. Some people it takes 3 minutes. They're like, done, never eating it again. I'm like, okay, and they're okay if they have diarrhea for 30 days. They don't care. They just, that's a small price to pay for not feeling suicidal. They don't care. Does that make sense? So that's how I do it.
Do you think that how did you used to deal with trauma and there's a lot of psychotherapy and I'm wondering really what we're seeing is a complete improvement in people's ability to have psychotherapy and see the changes by doing the deuterium depletion, going carnivore, the keto and paleo all help also. And it's just sort of a game changer because this really is areas that I'm not sure mainstream psychotherapy and mental dysfunction, trauma treatment has seen the benefits that we're seeing with carnivore.
No, they don't really understand it. I'm blessed that I've taken care of so many talk therapists and they come in and they understand. I leverage a lot of electromagnetics, right? A lot of neurofeedback and transcranial direct stim, things like that in the office. So my patients are getting like quick results while we're modifying behavior. It's very hard to change behavior when you're so uncomfortable. A traumatized person, we got to remember their activation is very low. Low energy, they're really tired. There's Laszlo. So what I do with them is I have to fill their charge a little bit before I ask them to make too much change. Most of what I'm doing is pretty passive. What talk therapists don't seem to want to remember, trauma is unconscious, nonverbal. So talking about it never gets it better. It's somatic. You have to deal with the body, and it's a mitochondrial disorder. Trauma is a overwhelmed breaking point in the autonomic nervous system where there's no more energy to sustain what's happening, and there's a crash below threshold. That is based upon the mitochondria. We must protect, preserve, and that's why that whole enzymatic steps of dehydrating, all that complication of glycolysis and TCA cycle is mitochondrial trauma, prep, and repair. It's trying to stop all that and fix it, because once they break, you break. So we have to deal with the mitochondria and the body and the water that's holding the memory, the fascia, to recover from trauma. Once I start doing that, that person has enough reserve to finally receive what the therapist is saying and practice the skills they're trying to ask them to do. When they're exhausted like that and they're in depletion, they can't even do it. So that's the difference. I love working with trauma therapists. I fill the people up. I deal with their mitochondria. I get their brain to hold a better charge. Now they can actually do their job, because what they do is very good, but they can't do it in a system that can't receive it. But they didn't understand. They don't understand brain inflammation. They don't understand charge. They don't understand mitochondrial health. And I'm going to get all that better with a carnivore diet, sunlight, sauna. There's some other things that we do for deuterium depletion, but we can, if Dr. Boros is here.
I was about to ask you what other things, because you mentioned the carnivore diet. What?
Yeah,
other
we can
things?
have Dr. Boros can talk about these other things
All right.
that.
So here we have Dr. Boros. You are muted, Dr. Boros, but if you unmute yourself.
I was trying to.
There we go.
Can you hear me?
Yes, now we can.
All right. Hi, Dr. Kias. Hi, Dr.
Boros,
How
welcome.
are you?
Fantastic. It's so nice to see you. And we're talking about with Dr. Rimka about deuterium depletion, the glycocalyx, physical and mental brain dysfunction, mind dysfunction, and how and why carnivore and deuterium depletion is so important. Maybe you could chime in a little bit and talk about that. Give us your insight.
Yes. So let's first just talk about the isotopes of hydrogen, because that's kind of important. We have 3 isotopes. Hydrogen is the parent isotope because that's the most common. So this is why we call it the parent isotope. And there's a stable isotope of hydrogen. It's called deuterium because besides the proton, it also has a neutron. And it has a radiating isotope or an unstable isotope called tritium, which has 1 proton and 2 neutrons. It's pretty much just like an apple basket. It's too big. If you put 1 extra apple on top of it, it just falls apart. So tritium is unstable, but it's very uncommon. It's only like 1 in 10 to the minus 18th. Practically, you can ignore it because it's a very, very rare isotope of hydrogen or anything. So, but it's bad because it's an unstable isotope. It has a half-life of about 12 years. That means it loses its activity in about 12 years if you have anything available of that radiating isotope of hydrogen. But deuterium, which is more common, it's about 1 in every 6,600 hydrogens. So when hydrogen drops through nanomotors, as you mentioned and you were talking about it, it actually is so large in numbers that it's going to hit a deuterium in a few seconds. So biochemistry or biology has to get rid of deuterium from glucose, sugar, and potentially fat. But fat is deuterium depleted because it's synthesized through mitochondrial citrate, which is deuterium depleted if everything goes well, meaning that you're eating a ketogenic diet from grass-fed pasture source. Those are the lowest in deuterium. Now, unfortunately, anywhere where glucose shows up, deuterium is high, simply because sugars or carbohydrates are enriched with deuterium because they come from fruits usually, and there's no deuterium depletion in the process when sugars are synthesized. So anything that has to do with sugar, either through metabolism or as a glycosylated entity, for example, membrane surface, mucus, and so on, and calyces, glucose has to be considered a deuterium trap, and deuterium has a different chemical behavior than hydrogen does. It's about 10 times harder to remove from a chemical bond. It makes water, interfacial water, very viscous. So practically anything, for example, mitochondria that only has interfacial water or structured water or membrane water, some people call it exclusion zone water. We don't use that terminology, but it doesn't matter. It has a different property. It's very structured, so it's very viscous. So if a deuterium gets in there from glucose or from any source, that would actually ruin mitochondrial nanomotors, membrane fluidity, and solvent capacities in cells and charge, as you mentioned. So practically when you compromise the nanomotor oxygen transport and water producing system in the matrix, then you also compromise charge, simply because electrons are also very important in this whole process to charge oxygen to form water after all. So it all comes down to, as you covered in your previous conversation, it all comes down to the role of deuterium in making sugar heavier, stickier, less capable of participating in metabolic reactions, and or making chemicals or structures in our cells more stable as well. So membranes are more rigid. So after all, you just have to control deuterium in various tissues, various intracellular organs below a certain level for sufficient ATP synthesis and charge, maintaining of charge, membrane potentials. So if you eat a low deuterium, grass-fed, natural ketogenic diet, especially with interiors with high fat content, those are very low in deuterium, about 110, between 100 and 110 ppm. So after all, you're going to be able to uh, preserve or protect these nanomotors from damage if you synthesize mostly ketone bodies or fat. This is practically what the essence of nutritional metabolic ketosis. So after all, this would actually relate to our energy transfers in our planet, because now what we are arguing is that practically the water, the sun, where the electromagnetic energy source comes to Earth from 150 million kilometers, it's actually a huge pile of water with a density of 1.4 gram per cubic centimeters, which is the density of water, and it's actually 10 to the 30th kilograms of protons, that because of nuclear magnetic events, sun is the source of the resonance scale that water can actually absorb on Earth because of the proton resonance and the proton bonds. So after all these grasslands, all these wetlands are able to absorb this energy through photosynthesis, and while they are producing organic materials with low deuterium, because deuterium discrimination starts during photosynthesis. So after all, if you're eating grass-fed animal meat, which is low in deuterium, just like the steak we ate with Dr. Kiotz in, I think it was Hermosa Beach.
Yeah, it was Newport.
It's in Newport Beach. That's the essence of deuterium depletion that starts from the sun, finishes in wetlands and grasslands, and where these animals are pastured. And practically that's the lowest possible deuterium to eat, consume from our nutritional kind of sources that we can eat. Anything different than grass-fed animals, meat interiors with high saturated long-chain fatty acids, which are the most saturated with hydrogen, that means provide the most energy for our cells, is dangerous, potentially dangerous to the mitochondria, depending on how much of those other sources you eat, fruits, vegetables, and so on. So you want to keep kind of carnivore and be part of this electromagnetic field that comes from the sun, and that's practically proton resonance, the visible light, and the electromagnetic ranges around that, the visible light energy scales, and then you can use those for your body through vitamin D, through that, or fat, hydrogen, carbon hydrogen bonds, and resonance. These molecules can absorb light energy from the sun through lights and light beams that penetrate through the skin and go all the way to the mitochondria when they are longer wavelength. So after all, this is just a ping pong game with light and heavy kind of ping pong balls, and that decides how well the game goes, or if the game is possible, simply because those nanomotors are very sensitive to deuterium because of the increased double weight and size of the nucleus. So when you want to kind of think of how nutrition and fertility play around, it's practically just, for example, when the egg gets fertilized, there's so many protons released and so many um, uh, nanomotors are starting in the same time in the egg. The sperm loses all of its nanomotors because only the DNA material penetrates into the egg. That actually the egg would give you a light shine, a little light. You probably saw that on YouTube. There was a paper just showing these fertilized eggs. There's so many protons, quantum delocalization and destabilization, and starting these nanomotors in the egg before they start dividing. After all, it's just even a light event is following these energetically very condensed, very dense events, physiological events in our body. So it's because of the difference between hydrogen and deuterium, and the difference in chemical behavior. The most reliable and the safest food source for us is grass-fed, grazed interiors and meat of. We usually eat just cows, but the sheep, goats, anything that has the split toes and they actually chew and regurgitate and eat grass mostly. That's their only source of food, and they have a very special teeth and anatomy for that, just to be able to chew those items. And that practically the key how the deuterium gets separated, discriminated, and fractionated throughout biology through the food chain of what is eating what, how much of it, when, or what source. And we are on top of the food chain, so we should not eat grass for many reasons, because they are full with toxins. Our digestive system is not cut out for digesting plants, but animals do all for that for us. We are carnivores by our teeth anatomy. We have teeth that are designed to eat meat and interiors. And for that matter, it's a very important argument, and it's a very important approach just to know how the deuterium is distributed based on nutritional. And go ahead.
Number one, if I eat a carnivore high fat diet for mostly ruminant animals, that's a very important step in decreasing the deuterium, right? Uh, Dr. Rimka mentioned sunlight. What other things can I do to minimize the exposure or the?
Can I ask a question? So let me ask Laszlo.
Sure.
I use a lot of molecular hydrogen, inhaling gas and drinking hydrogenated water for my patients. And I honestly never thought in my mind I was depleting deuterium. Am I doing that? And I didn't even know I was doing that.
Yeah, so this depends on what source you use for your hydrogen gas, because if it's industrial source, it can be high as over 200 ppm deuterium, depending on what the source of the hydrogen gas is.
Yeah, no, it's medical grade. It's medical grade. So I'm going to ask them about that, but thank you.
If it's hydrolysis, meaning that if it's an electrolysis system, depending on the electrodes, it can be low and high. The we recommend using deuterium depleted water in these devices just to make sure you are not releasing deuterium in excess, because of the change in the coating of these electrodes. There is an electrophysiological range. In some scenarios, deuterium oxygen bonds they actually get like faster broken by these devices. So what we do is we measure the water yield and we measure the gas yield from using isotope ratio mass spectrometers. Actually, we do have a set of samples right now, which we are measuring some of these electrolysis and hydrogen generating sources, devices. And if you are interested, I can give you some hints and some ideas of how they actually operate. But we haven't really found a reliable low deuterium source hydrogen gas device so far. It's just not any better than like tap water, for that matter. But hydrogen gas itself is, because it's a low mass, like small molecule, it's H2, it's only 2 Daltons, it penetrates through membranes very easily. So those are very light gases for that matter, so they evaporate very quickly. So you kind of, if you started measuring these deuterium levels simply because more and more people are using those, and we would like to see the data with those devices, and I'll give you some updates.
Okay. Yeah, I use deuterium depleted water. That's what and then distill it, and on top of it. But
yeah, that's the safest.
Yeah, that's.
Do you have any idea what else a patient can do for lowering deuterium besides light, sunlight, and grass-fed source? Do you
Well, I do cold. I mean, I do a lot of different things. So I do use a lot of, obviously, sunlight, but I use a lot of panels. So a lot of my people are like, they're in Detroit or they're in Canada. I mean, they don't have the it's snowing. I'm like, I get it. So I use a lot of red infrared light panels. I use PEMF as well. I'm doing a lot of stuff for the mitochondria. I use cold exposure, cold dunking, different things if that person can tolerate it to, do that.
Yeah, cold is very useful because with cold, you actually activate a decoupling protein. That means you produce water faster without ATP. That's why we call the process decoupling proteins, because then protons just shoot right into the matrix. You produce a lot of matrix water or deuterium with the right food source, with low deuterium, burning low deuterium ketones or fat. So cold therapies are very good. I usually go to sauna just to kind of go in hot and cold, sweat, and get rid of deuterium some other ways. But these are all very interconnected. As long as and also I live on the 7th floor, and I don't use elevators. So I just go and do a little physical exercise.
Healthy people can exercise, but the real sick ones, they're just they're just a mess. So I have to use a lot of the biohacking.
Yeah, of course.
Yeah, but we want them exercising when we can,
Yeah, indeed. Yeah, it's Go ahead.
What type of supplements would you recommend, or teas? I know you mentioned herbal medicines and things like that, Rimka.
Or like me, for clients with deuterium, I don't really love supplement. I mean, when it comes to deuterium depletion, I'm not trying to supplement them. Like a lot of the supplements have a lot of deuterium. So I'm not a fan.
That's a very good point right there, because the supplements are industrial source, most of them. And for example, if they are, like, just talk about vitamin D has to be a natural source and deuterium free, just to absorb all the photon resonance. And industrial source or chemically prepared vitamin D is not very useful for that matter. So like cod liver, I don't really have any particular supplement that I could recommend, but from natural, like beef interiors, liver, we
I think
cook
of
all
salmon
kind of-
roe as a supplement. I think of like fish eggs.
Yeah,
And
yeah,
it's not a
that's-
supplement, but most of my patients, I make it be a supplement for them.
as long as it comes from nature and like from a natural habitat, almost anything you eat or you can eat would be beneficial. Don't eat liver from polar bears because they have very high vitamin A content, so they are toxic. But any animal in your neighborhood, grass-fed and pastured animals, their interiors, liver, kidneys, and bone marrow and brain, and their meat products, especially the hind steaks, which are high in fat, with T-bones. Those are the best source of deuterium depleted water for matrix water production. And that's why, if my recommendation is just to use deuterium depleted water if someone is thirsty, but no, don't drink too much of it, just because food is better as far as producing your own water. But
I would say that. I would say that. Let me say what I do have to tell them, Dr. Boros and all of you. I have to tell them to stop drinking so much water. People have conditioned themselves, drink a gallon a day, because they join some hard 75 days, hard, whatever that's stupid, all these stupid challenges on the online world with all these social media influencers challenging their people, drink a gallon a day of water a day. So people are carrying, I mean, it's horrible. So I have to break that up a lot. And so to titrate people, and now they've ruined their hormones, right? The antidiuretic hormone, all this stuff. So their thirst signals are completely perverted. And I have to break up that myth that they're supposed to break. So one, the bigger thing is I stop the poisoning of all this excess water, which is always wildly deuterium laden, especially I'm in the South. It's all ridiculous down here. So there's that. If I used to make them buy the deuterium depleted water, I don't do it as much. I find most of the time we can do it without. If they have the money, they'll buy the deuterium depleted water and we'll switch things. And it's drinking that water. You asked, Dr. Nelson, that's another incredible way to start depleting. I just have to be careful with my clients, people with mental health issues, if that's what they're coming for. They're very obsessive, compulsive, and overtrack. And I'm trying to, they have a lot of neuroses around things. I'm trying to mitigate that stuff. I'm trying to tell them, you're already okay, you're healthy, you're whole, you are not broken. And so I have to be careful how much interventions I do and how much tracking we do, because they have to stop seeing themselves as a medical experiment, as a diagnosis. So one, I stopped the drinking of all the excessive water. That already is a massive thing. And teaching
I agree.
that's a huge thing. Thank you for bringing that up. But that's a major problem.
Yeah. What you really need to think of, like water, is you can die of water poisoning by brain swelling, and it's a very serious medical condition. If you drink a liter and a half water with no salts in about 20 minutes or so, you definitely going to have a headache, and if you keep going, then you may die.
Yeah. So there's a question. They're asking about fasting and iodine. I don't know if Rob, you want to bring that up, but I don't find iodine to be a major thing with mental health issues at all, unless it's thyroid driven, which there's a lot of mental health problems that are actually thyroid disorders. That is a non-issue. That is not a big thing I deal with. And do I give people iodine? I do, but that's not going to be the crux. It's not going to do what zinc is going to do. I'm going to tell you, zinc deficiency is probably the biggest cause of all the mental health problems I see.
And fasting, both dry fasting and just, I just did a 3-day fast, and I actually did a dry fast 3 days, which I haven't done that many days of no water, and I'm just testing my ability to do it, and I felt great. But it's interesting. I rehydrated with some mineral waters, and my gut just emptied. It was like but it happens sometimes after a few days of fasting like that. I'm not quite sure why that happens still, and wonder if something about the glycocalyx or something going on that happens. The diarrhea.
I don't know, but what Dr. Boros said, when we talked about the glycocalyx, and we're saying, well, I don't know, let's ask him about deuterium. Does it directly impact it? But right, deuterium's job is to make things heavier and stickier, right?
Yeah.
So it's making it like, oh, right, of course it's damaging the glycocalyx because you don't want the glycocalyx stickier, and heavier. Like, so do you know stuff specifically about what that would do? Like, I mean, fascinating.
I heard
On top of
people
everything.
complaining. Yeah, I heard people complaining the same, having diarrhea when there's a water load. Simply, there might be some personal inflammatory issues during the fast. These are very transient and very minor in the sense that how water is absorbed. Diarrhea is practically a very important sign of not being able to absorb more water through the small intestines and the large intestines. And if your microbiome is compromised or less in mass simply because you have not been eating, or if you're fasting, then it may affect your water absorption. It's not necessarily anything other than just you're not able to absorb water as efficient as when you're in a fat state and you have solids and your water is acting also as a solvent. If there's nothing to dissolve, then your water is osmotically, it just kind of runs through the system, I believe.
And I probably drank too much at one time. I think.
Yeah, if you don't drink by thirst, if you over drink, meaning that you drink more, it's a dipsynogenic form of like an insipidus situation. When you actually drink too much, you cut down your antidiuretic hormone release and you start passing water through urination and also through diarrhea. So it's a pituitary gland related issue. ADH, antidiuretic hormone, when you have too much water intake, then this hormone shuts down because of the swelling of the pituitary gland, which sits in the sella torsica. It's like a bony little structure. So if the pressure increases in your pituitary gland, it shuts down your ADH synthesis, meaning that you start urinating and you start getting rid of water any way you can, and your bowels are not able to move as fast, and they are not able to absorb water efficiently. So you're trying to get rid of water if you drink too much. The other important thing is that if you keep drinking too much, it's not only compromising your ADH release, which is from the posterior lobe, but you also compromise FSH, these sex hormone regulatory releasing factors, the production of those. So infertility may set in simply because you damage your pituitary gland because of the swelling. And for that matter, you have to start with cutting back on water and put them on the right diet.
I feel like I'm back in school. This is wonderful.
I know. Yes, he'll do that to you. Yeah.
Is the water in fruit deuterium depleted? Dr. Rimka.
I don't know. It's the water. Okay. I mean, I would say no, but maybe all the deuterium's in the glucose. I don't know. Laszlo, do you know that? I know where people get the benefit of, like when they juice fast or so they feel better. I'm like, well, it's structured water. They're getting this structured, better water. Is the water that's in the fruit deuterium depleted? It's in the sugar? I mean, I don't know. It would seem like it wouldn't be. I would think no, but that's me guessing.
So what was the question again? I'm sorry. Let me turn off.
Is the water inside fruit deuterium depleted?
No.
Yeah,
no.
I didn't think so. I wouldn't think so.
No.
But yeah, I'm like, is that a trick question?
No.
Yeah.
Fruits are
Super
not
deuterium
depleted. They are actually very high in deuterium for a very simple reason. During fruit production, there are no mitochondria present. Practically when the flower and the female plant organ is fertilized, then it's practically just a glucose producing photosynthetic cycle, and there are no mitochondria involved in the process. So you practically just leave this whole deuterium depletion scenario out. So your fruits are going to be very high in deuterium, and the water source and also the solid sugar source as well from fruits, they are actually 155 ppm or higher. The highest we measured was, I think it was peach, up in the 160 range. And wine and grape, those are also 160 ppm because of the high deuterium content in fruit sugar. So it's not low in deuterium, not at all.
And I live in the peach state. Isn't that great?
You are?
Georgia peach. Oh gosh. Yeah.
Okay.
Do we have some other questions there, Dr. Nelson?
Oh, there's a bunch of questions. It's past 5:30, but
we got a few more minutes. We have some, the two
I can go for the next few hours.
Are you guys okay with a few more minutes, Dr. Rimka?
I can do a few more minutes, yeah.
Yeah.
All right, let's take them in order. Like we have blood work today. Fasting blood glucose went up to 110. I've been carnivore for 5 months. Why?
One, I don't really care about fasting blood glucose. I don't know how you feel, Rob, but that doesn't mean a lot. It could be anything. That could be white coat syndrome. You didn't sleep last night. I mean, you ran across the parking lot. I don't know why that happened.
It's a snapshot. It's a snapshot of a one moment in time, and you don't know what else was going on.
Yeah. Well, I just someone gave me a glucose monitor, and I never used them, and I did it last month, and I did this month. I just for 10 days.
Yeah.
And I watch it sometimes, and it goes way down or goes way up, and I'm not doing anything different. I actually went through a 5-day fast, and I would see it go like to 46, and it hover down there, and then it come up again, and it didn't have much of a rhyme or reason. I never went high, but and now I have a new monitor, just a different thing that attached to the skin. And now I'm in the 70 to 90s, and I can't tell you them anything different. It's just.
I don't know why sometimes it just pushes glycogen out of our liver. I don't know either sometimes, right? Like,
well, let's
A1C, but I don't know what the one.
Yeah. So once you become a carnivore, once you get in ketosis, you start to absorb and you start to metabolically process triglycerides. Now, triglycerides have fatty acids, 3 fatty acids. You can, by lipase, through absorption, through digestion, you can absorb 3 fatty acids and glycerol itself. Now, glycerol is a gluconeogenic substrate, meaning that your liver can phosphorylate glycerol and make glucose from it. So if you're oxidizing or you're metabolizing a lot of fat because you're in ketosis from your adipose tissue, which releases free fatty acids and triglycerides, from your liver, there are also triglycerides released in the circulation, then the leftover glycerol gets back into the liver and you start producing glucose from glycerol through gluconeogenesis. And it's also needed for tissues to produce some anaplerotic oxaloacetate for your cells. So practically especially muscle cells, so practically you can swing, you can see low and high stages of glucose based on where you are in ketosis or in your ketogenic state. It's not necessarily a low glucose state.
Right.
It depends on how much glucose is getting produced based on the triglycerides that you're metabolizing. So it can be anywhere in the normal range in the sense that, or even above the normal range in conventional lab results. But once you get in ketosis, there are no normal labs anymore, because nowadays the normal labs are kind of the normal of the average or the expected
Yeah.
results that are actually not in a ketogenic state.
Mhm.
So our labs are different than labs of the population.
You mean LDL cholesterol is not going to kill me?
No, no, it's actually very good for you. Higher is better.
God bless everybody.
My cholesterol is 12, and I'm very happy and proud of it. And I'm showing it everywhere.
Yeah.
And my doctor is asking me like, how is it gonna? I'm like, don't worry about it. It's just
Yeah.
we have to look at lab results differently. That's all.
Yep. I agree.
Think 316 asks thoughts on raw milk.
I'm a fan.
And then raw meat and raw milk compared to cooked meat and pasteurized milk.
I mean, I'm a fan, but listen, humans like fire. We've been using fire a long time. I'm not eating raw meat unless
Like
it's
to burn
like,
things, don't we?
listen, yeah. I was a vegan 12 years, you guys. You got to give me, I like my stuff medium well. And I know it's like I'm blasphemous to the carnivores. So, like, you really do that to your filet? Yes. Listen, back off. Like, I'm doing the best I can. I can't do medium rare. So, I'm cool with people doing that. Like, I get it, you know, but I love raw milk. I like A2 casein. I will take patients off of all dairy, though. I have certain conditions when the immune system modulation is a little chaotic right now. If we have a lot of mast cell disturbance, if I have thyroid issues, I pull them off of all dairy. I don't like any pasteurized dairy whatsoever. I think that's all pro-inflammatory, but some people can get away with it, you know. Other people cannot. So I will take a lot of people off all dairy for a while. I prefer raw A2 casein, so a goat or a camel or the right kind of cow before we hybridize them and stuff like that. I find that can be incredibly, nothing better than human breast milk, by the way. So that's always, I do like species specific, but I like that. So
Well, I was going to ask, so my daughter has been breastfeeding, but she had to go do a conference today. So she froze as much as she could, but Julio just, it may be a little short on how much.
Oh,
we were talking about, and I said, don't do it, but they tried like a little bit of formula and he didn't tolerate it at all.
Yeah.
And so what would be a substitute? Would it be goat milk, raw goat milk, or do you have any other thoughts on
there's some formula? The Weston A. Price has some really beautiful formulas for that. I certainly don't want to come up with the baby milk substitution, but they have some of that. So I think, I forget if it was sheep is the closest to human. I forget the configuration.
Goat.
Don't quote me. I don't know if is it goat. It's sheep or goat. It's one of them. But the Weston A. Price has some beautiful recipes for mothers to make their own if there was any type of issue. My son was the same way. 3 years breastfed. He wouldn't touch a nipple besides mine from any other source. That was like, you can take that thing. Like, don't worry. I'll be a cow. I'm happy to give him life. That stuff's miracles for anything. You put breast milk on a cut, a scrape, pink eye. I mean, that's the world's greatest antibiotic. If you have like you, who's got breast milk? If I had friends come, like I literally have used it for things like, you got some breast milk? Can I have some? You can do it with cure all kinds of things. It's magic sauce. The idea that they're telling you Nestle can make something better than me. Talk about the greatest gaslighting story ever. I like methylene blue. I use a lot of methylene blue in my practice. I've used it for quite a few years. I do a lot to support mitochondria. I use peptide therapy. I use light. So one, you got to figure out what happened.
Yeah, that's the only thing I can kind of reason with is methylene blue as a supplement, nothing else. But methylene blue,
I use a lot of methylene blue.
Is something I could.
How does it work?
It's a very complex molecule, and it has a very unique structural complexity that we actually published on this with Dominic D'Agostino and Dr. Shomiai. How structural Gleevec is the drug that we investigated in this particular matter, and it actually has some deuterium scavenging
Oh,
capacities because of the bonds that they can. So actually, structure is very much determining how protium or hydrogens and deuterium attach to it based on the structure. So methylene blue seems to be very efficient. So is ivermectin, and you know the malaria drug, because of their charge states, they have very unique and efficient deuterium scavenging mechanisms in and within cells and organs. So those methylene blue is definitely like a supplement that can be used for this
yeah.
scenario,
It's one thing. It throws in this free energy to the electrons, able to
among others. Yeah.
among that, it kind of acts like oxygen, sort of. It helps move things along in a low oxygen state. It kills things, that's antimicrobial. It helps with neurotransmitters, so it's very good for mental health. It helps upregulate.
Yeah, I agree. It's
a lovely thing. It's not going to fix the structural problem. Like I might use something like SS31, a peptide to kind of an architect to go inside the inner mitochondrial membrane. I use a ton of phosphatidyl serine and phosphatidyl choline. I had put a lot of that in. There was another question about somebody with chronic fatigue syndrome, things like that, because I'm trying to figure out what it is. One, and you need to work on your vagus nerve, vagal tone, the nervous system. That's a big part of this, everything here. And then whatever was damaging the mitochondria, you got to stop it. Oxalates damage it like crazy. Lack of sunlight is going to damage. Lack of temperature, lack of cold and heat. If you never are regulating your temperature in any kind of way, it doesn't, the infrared light that's given off and the heat waves, you need to get in circadian rhythm. You need to start respecting nature. You need to start waking up with the sunlight, eating with the light, going to bed, stop eating in the dark. So all of those things matter. You can't be taking Cipro and think your mitochondria are going to work either. So there's a lot of things. We got to stop poisoning them. We have to repair the structure, the inner and outer membrane, and we may need to do some things to donate energy and take the place of oxygen, like methylene blue and
I like the
and humanin and things like that as well.
So. I like the way Kennedy handles this as the secretary, and also Trump pointed Casey Means as Surgeon General, and she works with Dominic D'Agostino. We wrote the first deuterium paper together with Dominic. He runs her Research Foundation's advisory board. So it seems like kind of we are getting closer to making this a more comprehensible, more comprehended, and more influential. I was actually trying to get in touch with Dominic because of the nomination just recently. So in the next few days, we're probably going to talk about potential fitting applications. Go ahead.
There's a question. That's a really good question. I love this. They go, aren't these hydrogen isotopes naturally occurring in the correct healthy ratio in nature, or maybe chemtrails, pesticides, cell tower radiation messing up the equilibrium?
Yeah, that's
I think they're manipulating the temperature and the weather like nobody.
Yeah.
I think we've been in temperature weather wars for
decades.
That's
what GMO is about.
Yes.
That's what GMO is about.
Anymore. No.
To load for years, just to load these plants with deuterium through irrigation systems, through glyphosate, genetic modifications, enhancing their yield or productivity with artificial fertilizers and organic stuff that is really not part of the plant's microbiome, because those plants also live in connection and in company with other prokaryotes, especially in the root system. So, and you're right, processed food is practically a deuterium bomb compared to the grass-fed meat source.
Yeah.
So I have about 50 more reasons now to be a high-fat carnivore.
Yeah.
To start with.
Okay, I'm gonna go because it's getting
Laszlo.
late here in
We got-
Europe. So
Laszlo, a pleasure.
Thanks.
Dr. Rimka,
Great
a
honor.
pleasure. Stephanie, thank you. And everyone's questions and just being here today. And Dr. Nelson's really been a plus in helping us really share more important information for everyone. So again, I know where we're going to see you in America soon, Laszlo.
yeah, I'm planning because there are gonna be a few events that I need to come and cover. Maybe meeting some of the people in policy and administration. I'm definitely gonna want to talk to Dominic D'Agostino about how these new developments can help us. I'll let you know if I
All
come.
right. Well, we appreciate that. Stephanie,
Thank you very much.
Thank you.
My pleasure, guys. Thanks for doing your work.
All right, Al. Take care.
See ya.
Thank you. Have a good
All
one.
right.
Thanks so much.
Have a good night, everybody.